Hi guys, and welcome to this video on multiplying and dividing terms. My name's Darren, Maths Guru. Really good to see you. Thank you very much for stopping by and watching this video. If you can, like, subscribe, tell people, teachers, parents, friends, TikTok. Yeah, anyway, I'm just here to try and help as many people as I can with my own strange way of teaching. If you watch my previous videos, you'll know that I deal with kisses and bunk beds and prison guards and all such things to come. So I do it very much by stories, and I still have people now 20 years later going, Mr. Smith, kissy. I'm like, okay, moving on. So what are we doing today? We are looking at understanding the meaning of square and cube terms, multiplied terms and simplifying results, and able to divide terms and simplify them. Where we said about floaty numbers, and if you remember, we've got bid maths, we need to know about bid maths. All right, that's floaty numbers. That tells me how to deal with brackets and indices. Well, indices are floaty numbers, right? They are numbers what float. So an example of that might be, for example, a squared. This here is an index or a power. Yes, so that's going to come in helpful a little bit later on. But we now know that that floaty number just tells you how many times A is multiplied by itself. So in this situation, that is A times A. Now, when we go from this form into this form, we are using expanded form. It can also be called expanded notation. All that means is we're expanding things out by putting all of those kisses in. And again, there we go. There is my kissy between numbers and letters are kisses, timeses. And that becomes really, really important later on. So if we have A with a floaty 3, that would be the same as A times A times A. And so it goes on. So knowing about those floaty numbers, really, really important. What about if I now have A, B with a floaty 2? Well, if I wanted to write that in expanded form, then that would be A times B times B. Why? Well, we've got B with a floaty 2, and there's my two B's. And it's very, very important in maths to realize that at the moment, that floaty 2 belongs only to that B. Later on, it'll start belonging to other things, but if there are no brackets, then that floaty number belongs to just that letter. So that's going to be very different from A squared B, which there tells me to do A times A, two A's and a B. All right, so that is sort of the start of where we're going from, multiplying all of these terms together. Now, also in a previous video, so another recap, he says writing recap, was we had the idea of 7AC and 3CA, and whether or not they were like terms. So remember, like terms are they have exactly the same letters in them. Now, I quite like that, all right? In this situation, that has an A and a C and a C and an A. But what did I tell you in that previous video? I told you that order is actually important. Now, by that, I mean that if we can write the letters in alphabetical order, it'll actually make our life a lot simpler. So, realistically speaking, we would have written that as 3AC and 7AC. And then we can see that they are most definitely like terms, right? They are like terms because we've got the A and the C together. But expanding it out, that's 7 times A times C, and that's 3 times A times C, or kissy, yes? Like terms. Another bit of a recap, just going back to the basics, is way back in junior school, you probably would have done 2 times 3. What's 2 times 3? 6. Not particularly complicated. But what is 3 times 2? It's also 6. And so what I told you previously in a video was that so long as things are multiplied together, we can happily change the order. It won't change the outcome. So what I'm saying here is we changed the order of the 3 times the 2, but we noticed that our 6's stayed exactly the same. Our outcome was the same. So that would suggest that 7AC, which can be written as 7 times A times C, is also the same as 7 times C times A, which is the same as C times A times 7, which is the same as A times C times 7, and I could go on. In fact, there's only 2 more that I could have done. So in this situation here, again, because they're all multiplied together, the order can change. Now, why is that going to be important to the lesson we're about to do? So this is the new learning. What if I want to multiply terms together? Previously, we've added and subtracted. That's my shopping cart and whatever else. But what if we now want to multiply these things? So here's an example. What if I have 7a times 3b? Well, the trick to this is realizing that all of those are actually multiplied together. And by writing things in expanded form, we start to see a way forward to answering these. So remember, between the 7 and the a is the kissy kissy. Between the 3 and the b is the kissy kissy. And this final one here in the middle is written here in the middle. So I've just written that now in expanded form. And I've just told you that we can change the order of these things without changing the outcome, right? Our final answer. Now remember, what did I say always comes first? We always put the numbers first, then we do the letters in alphabetical order. So I'm now going to move this around to become 7 times 3 times a times b, and there we go. Now, can I simplify this? Yes, simplify, remember, is being able to make something look easier. And the best thing we can do now is simplify the 7 times the 3, which gives me 7, 14, 21 times a times b. Now we're not substituting, there's no value of a and b. We're now just going to simplify that again by effectively taking it from expanded form to non-expanded form. Don't know what the opposite of that is. And so in this situation, I know that where numbers and letters are connected by timeses, I can effectively get rid of the timeses. So that becomes 21 AB, and ladies and gentlemen, there is my answer. Ka-ching. Oh my goodness. Now again, if you want to, stop it, rewind it, go and look at other examples, see what you need to do, but I'll do another example for you now, e.g. 2. Let's do 4AB times 3AC. All right. Now again, following the rules through, and that is write it in expanded form. Right? When you're multiplied together, write it in expanded form. As you get better at this, you'll be able to do it straight away. But we're still learning. So I'm going to write that as 4 times A times B times 3 times A times C. All right. Looks disgusting, yes? But all we've done is put the times in. So number one, well, the first thing we did was we expanded it. What do we do then? What do we do now? Well, number two is we reorder. And by that, I mean put the numbers first and then the letters in alphabetical order. So we've got a 4 and a 3. Now, it doesn't matter what order they're in. I've got, how many A's have I got? I have 2 A's. I've got a B and I've got a C. So all I've done is reorder these things. And now I'm going to simplify anything that I can. Well, I know that 4 times 3 is 12. I've now got another trick here to say I've got an A times an A, which we know mathematically we can write that as A squared. I've got nothing to connect the B with. I can't simplify the B or the C. Having now made that simpler by the numbers and any repeating letters, I just basically stick it back together again. So I've got 12, A squared, B, and C. If you showed your parents this now, they'd be like, oh my goodness, you're doing higher order mathematics, which really this actually is. But what you're really doing is just moving numbers and letters around and putting them in alphabetical order, right? You learned that in junior school. So let's just do number 3. What was number 3? We were simplifying. And then number 4 was effectively remove all the multiply signs, remove time signs. All right, so there we go. So that is in essence what this whole lesson is going to be about. It's about the idea of following those 4 stages: expand, reorder, simplify, and then remove the time signs to be able to simplify when multiplying terms. All right, that's what we're doing. So we're multiplying. So let's take an example from the Cambridge textbook. And thank you very much, Cambridge, for allowing me to use your examples. You guys rock. Okay, again, I put my equal sign there. So I'm going to write it in expanded form. 7 times A times 2 times B times C times 3 times D. Now again, don't get tricked here. Make sure that we can only do this when the terms are connected by timeses. And remember, there is a term here, there is a term here, and there is a term there. So those are my 3 terms connected. What can I do now? Well, we've expanded it. We're now going to reorder it. So I'm going to put all the numbers together. 7 times 2 times 3 times A times B times C times D. There we go. Right, let's do some simplification. We can simplify 7 times 2 times 3. Well, 7 times 2 is 14. 14 times 3 is 28. I can't do that, so I'm going to do it the other way. 2 times 3 is 6. 7 6s are 42 times A times B times C times D. And there's no way of doing anything with those letters, and I'm just going to write it A, B, C, and D. Woo! And they say algebra's tough. And here's another example, 3xy times 5xz. All right, so how many terms do we have? We've got 2. They're connected by a times, which means I can now expand it. So 3 times x times y times 5 times x times and z. We have to be very careful with our z so that it doesn't look like a 2, or we can make silly mistakes. Equals, what are we going to do now? So we've expanded, we now reorder. So 3 times 5, numbers first, then letters in alphabetical order. So x, there's 2 of those. There's 1 y, and there is a z. Right, so we've done that. We are now going to simplify. We know that 3 times 5 is 15. We've got 2 x's next together with a times between them. So we know that becomes x squared. And then we've got the y and the z, which I can't do anything with. Can't do any more simplification. So I'm now going to suck it all back together. 15 x squared, y, and z. And ladies and gentlemen, multiplication is freaking awesome. Right? Love, 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 love multiplication. The one that tends to throw people is division. Right, now, why does division throw people? Because generally speaking, we didn't like dividing when we didn't like fractions when we were at junior school and we got all that rubbish in our head. It's fine. We can deal with this. So what I'm going to do is I'm going to show you something first that's pretty funky. And I'm going to ask you a question. What is 1 divided by 1? 1. Congratulations. I don't know why I was waiting for you to help me there. What is 10 divided by 10? 1. What is 312 divided by 312? 1. And the reason you know that is because somewhere you were told that anything divided by itself is always 1. Right? If I've got 10 friends and 10 sweeties, we'll get 1 each. That's what that means. It's sharing, because sharing is caring. Okay? So what I now know is that if I have a number on the top and the bottom of my fraction that is the same, then I can effectively cancel them down to become 1. And again, another way of doing this is if we got a 2 on the top and a 2 on the bottom, we know that by cancelling down, we can divide the top and the bottom by the same number. So they're both divisible by 2. 2 divided by 2 is 1. 2 divided by 2 is 1, and 1 divided by 1 is 1. So any number divided by itself is 1. How does this help me with algebra? Okay, so if I have A divided by A, what does that give me? Well, again, the rules are still true. A divided by A, anything divided by itself is 1. What would AB divided by AB be? Again, doesn't matter I've got 2 letters. Is the thing on the top exactly the same as the thing on the bottom? Abso-chuffing-lutely it is. So again, that is going to become 1. Now, actually, we can split those things up. And we know that that's A times B divided by A times B. Well, hold on a moment. I notice I've got an A on the top and an A on the bottom. And I know that anything divided by itself is 1. And I've got a B on the top and a B on the bottom. And I know that anything divided by itself is 1. So what I could really do is say, well, A divided by A is 1 on 1. And B divided by B is 1 on 1. And so what that now becomes is that's become 1 times 1 divided by 1 times 1. 1 times 1 is 1. 1 times 1 is 1. And that becomes 1. Oh my goodness gracious me. So what we're actually doing here is we are cancelling using letters by checking to see if there's a letter on the top and a letter on the bottom. Now, beware. This only works when the tops are all multiplied and the bottoms are all multiplied. All right, so beware, tops and bottoms must be all multiplied. Now what I mean by that is if I had A plus B divided by A times B, this is not going to work. The reason being is that plus sign there stops the rule from working. So this won't work. So let's do some examples and I'll show you, because generally speaking, doing examples is the best way to see. And oh, okay, I get that now. So let's do this one. AB divided by BC. So first things first, ask yourself the question, is the top multiplied together? Yes. Is the bottom multiplied together? Yes. Okay, so now when there is a letter on the top and a letter on the bottom that is the same, we can cancel them out. Now again, I don't like the idea of cancelling them out. What we actually do is we say, well, that becomes a 1 and that becomes 1, because we know that B divided by B is the same as 1 divided by 1. So what do we now have here? We end up with A times 1 divided by 1 times C. Yeah, that 1 is in the place of the B now. So A times 1 is A, 1 times C is C, and lo and behold, my answer becomes A divided by C. I can't simplify it, can't do anything else here. Yes, it's a fraction, don't panic, it's fine, but this is the general idea of what we can do with letters. What about if I have 2B on 4BC, for example? So always ask yourself the question, is the top multiplied together? Yes. Is the bottom multiplied together? Yes. Okay, so we can now do this cancelling out, this simplifying. All right. Is there a letter on the top and a letter on the bottom that was simple? Yes. So B, that becomes 1, that becomes 1. All right, so I've got 21 on the top. All right, so what have we got? We got 2 times 1 on the top and 4 times 1 times C. Well, 2 times 1 we know is 2. 4 times 1 is 4, and times that by C gives me 4C. And there is my final answer. Yes? Because again, we get so used to doing this only for the letters, we forget to look at the numbers as well. So had I written down 2 on 4 as just a fraction, I'm fairly sure you guys would say to me, hold on a moment, you can simplify that. And I'd be like, yes, you can simplify that. Because again, 2 on 4 is the same as a half. And so you have to do the same thing there with the numbers. So when you're doing this, you must make sure you look for the letters and the numbers. So that leaves the 1 on the top and 2 times C on the bottom. And so my answer becomes 1 on 2C. Let's do another example. All right, and I don't think there's too many examples we can do because this is really important. All right, so here's another example. All right, are all the tops multiplied? Yes. Are the bottoms multiplied? Yes. So I can now do my cancelling out business. So let's do the letters first. Is there a letter on the top and the letter on the bottom that's the same? Yes, B. So again, that becomes 1 and that becomes 1. So we've done the letters. Now make sure we do the numbers. We've got a 10 on the top and a 15 on the bottom. What is the highest number that goes into 10 and 15? 5. Now this helps if you know your times tables. So 10 divided by 5 is 2. 15 divided by 5 is 3. So again, if I'd written 10 on 15, the chances are you would have eventually got to 2 on 3. So now let's write this out long ways. We've got 2 times A times 1. All right, so there's the 2, there's the A, and there's the 1. Divided by 3 times 1 times the C that's left. And let's simplify that. 2 times A times 1 will just give me 2A. And 3 times 1 is 3, times that by C gives me 3C. And believe it or not, we've done it, right? So fractions tend to trick people, but there's no reason why they should. Here we go, so let's do another one. So always ask yourself the same 2 questions. Is the top multiplied together? Yes. Is the bottom multiplied together? Yes. Now, where are they trying to trick you? With that x squared. So I'm actually going to write this out in expanded form. All right, now notice if you notice I haven't put the brackets yet, I haven't put the multiplication signs in there at this moment in time, because it just leads me to a little bit of confusion, but same point. So let's now look. Still multiplied on the top, still multiplied on the bottom. Are the letters on the top and bottom the same? Yes. So one of the x's cancels with one of the x's there. Now they don't both cancel, because remember the rule is one thing on the top, one thing on the bottom. If they're the same, becomes 1 on 1. So there's the letters done. What about my numbers? 18 and 8, they are both divisible by, we'll say 2 for the moment. So divide that by 2 gives me 9. Divide that by 2 gives me 4, and I can't go any further. So if we now look what we've got 9 times x times 1 times y. So we've got 9 times x times 1 times y, divided by 4 times 1 times z. Oof, okay. So we now know we can do 9 times 1, which is 9. And then we get the x and the y, right? Because they're all just going to join each other back. And we've got 4 times 1, which is 4. And we've got the z there. And ladies and gentlemen, there we go. Now, again, they look complicated. Stop the video, go back, watch it again. Try and link it to other videos that I've done. And I promise you, you will get this. This stuff is freaking awesome if you practice. And yes, you're going to make mistakes, but don't worry about it. If you make mistakes, that's how you learn. You put your hand up. Excuse me. Show you're working out. If you try and do this in your head, no one's going to be able to check you're working out. But by doing each stage as I've shown here, you are going to have a maths teacher who's going to think you are freaking awesome. Now, just to give you some more practical examples of how they might do this in other questions, remember we can mix the learning that we have done previously. So there is a shape, and I'm going to now tell you that this has a height of 2a and a width of 3b, and I want you to find the area. Now, if you're remembering how you find the area, I always do one right angle and I look at the two sides I'm going to multiply together. All right. Now again, don't worry that these aren't numbers, follow the rules. We know the area is that times that. So my area is going to equal 2a times 3b. Now again, we're not going to get a physical number of this. We're not going to get a number, but we are going to start to use our area stuff and our algebra stuff. Oh, hold on a moment. This is the stuff we were just doing a moment ago. So I can write that out as 2 times a times 3 times b, so I can expand it. Then I'm going to smooth things around, all right? I'm going to swap things around to become 2 times 3 times a times b. And then simplify it. I know what 2 times 3 is. It is 6 times a times b, and so 6ab. Now, again, because it's an area, we should write units squared. But again, what we've now done is we've mixed algebra with area. And the problem with lots of year 8 students is that you guys want to now have physical numbers, because all through year 7 you dealt with numbers. Year 8 up until now, numbers. Now we're going to start dealing with letters, but the basic rules stay the same. We know how to work out the area of a shape. All we're going to do now is put letters in, and we're going to start to pattern spot to see, well, when are we going to multiply things and like terms and all that type of stuff, and when are we going to divide it. One last example, I really like this one, is giving you the question backwards. So we're now giving you the answer, and we're asking you to find the value of what would go in that box, such that this, when multiplied, would give you this. So we've got 3 times x times something times z gives me 6 times x times y times z. Right, okay, so we've got one x on this side that matches the x on that side. That's awesome. We've got a z here that matches that z there. We don't seem to have a y anywhere on the left-hand side. So that's my first hint. I'm going to need to have a y in there. All right, oops, I have shortcut the answer a little bit. Let's put that back as a 3. All right, so that's the letter. All right, this was the letter I was missing. I've now got that there. So what am I now going to do? Well, I'm now going to look at my numbers. Always look at letters then numbers. I've got a 3. It's turned into a 6. How is the only way I can turn a 3 into a 6 using multiplication? Oh my goodness, that would therefore have to be a 2. So what I've now done through a process of elimination is that value there would have to be 2y. And again, if you want to, then go and work it out and make sure that it's all worked. Did you just see the answer to that one? God, you are clever. Ladies and gentlemen, I'm done. Thank you very much for watching this video. More on its way. If you can, shout out, let other people know. Teachers, friends, TikTok, Instagram. Otherwise, hopefully I'll see you in another video. Take care, guys. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is mathsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.